I mean, like, I feel like if you knew that I was if you knew that I identified as a robot, then you would know how to feel about me. Hi, my name is Yusuf. I've been a hobby graphics programmer for about a decade now, and I'm attracted to graphics because of the connection to my first video game experiences, to the problem solving and enrichment, and the creativity and artistic side that it has. I'm experimenting with a new video format. I found that the YouTube algorithm initially it challenged me, and because it challenged me to make better videos and to think about things from a marketing perspective. So I thought it was making me more creative, but ultimately I haven't made videos for months, and I think it's been actually punishing me too severely for deviating from the first few ideas that did well on my channel. So technically it's made me less creative. So now I'm trying to basically abandon the algorithm and just do my own thing. And having a separate full-time job really helps with that. I'm also really inspired by a YouTuber named Soding or Szoding, who is a recreational programmer whose video format is a large inspiration for this experiment. I'm also currently live streaming this on Twitch at Yusuf28_, and in the future I may do so again, so feel free to follow me there if you want to interact. So today we're diving into an article by Inigo Quiles, and it's on creating fractal terrain using only SDFs or SDF grids. Now IQ or Inigo Quiles is a graphics programmer and a mathematician who formalized and popularized real-time SDFs, real-time sign distance functions for computer graphics, modeling, and I think animation as well. So the goal here is to see how far I can get into his article in about an hour, explaining and exploring some things as I go, and then uploading the entire journey on YouTube. So let's dive in. There's traditional noise or FBM, which is fractal Brownian motion, which can be used as a displacement to an SDF. So basically, the simplest way to explain it is if you have like an SDF plane and then you add a sine wave onto it, then you can make it kind of like lumpy because you're displacing the distance. You're displacing the coordinate system or the distance that was generated from that system. And so it's kind of making it look like it's not. So this is an SDF for a square, right? Now, if I add a sine wave to it, I think I'm jumping ahead, but okay. If you add a sine wave to it, it can go like this. So I'm adding a sine wave to the distance that was produced by a box function in a coordinate system. And as you can see though, that these lines, which are supposed to be like evenly spaced distance lines, are now being distorted. So that's what a lot of these functions do, including this one, which is, this is one of my shaders that I wrote that's basically a fractal terrain. And as you can see, it looks good, but underneath the surface, it is actually distorting the distance field quite a lot. So in some cases, that won't work. So what IQ is suggesting is that there's another way to create a sign distance field that looks like terrain, but that doesn't have that issue of being like of distorting the underlying distances. All right, so right, so that's this article, FBM detail in sign distance function, and I'm going through this article and I want to try and make it starting with this. Like, this is basically my template for making shader projects. So the way he's getting around this is by saying that the most important part of this process, of this FBM fractal addition, isn't the fact that you're adding something to, it's not arithmetic, like you're not adding to the distance, it's actually about the fact that you've got different sized layers of, repeated stuff. So he's saying that you could define a new type of addition instead of like addition, meaning you're adding a distance. He could say you could add another SDF. And so that's basically what this article is trying to do. Like a sneak preview is that his plan is going to be to take grids of sign distance spheres like this that are like kind of like randomly sized, and use different layers of them at different scales to create another sort of sign distance fractal Brownian motion that's where you add those together instead of trying to use like a function, okay? Can you picture that if you had a grid of these, and then on a different layer, a different level, you had a grid of smaller ones and then smaller ones and smaller ones, that it would start to look more like a natural shape? Maybe, but now you're probably wondering, okay, but how do you make it look like mountains? If you have like basically a cloud, I mean, it's just like the whole space is filled with these. If you do that repeatedly and repeatedly, you're not going to be left with anything resembling terrain. You're just going to not, like, it's just going to be a whole bunch of this stuff. So what actually has to happen is we have to carve out a space where these grids can exist, and then anything outside that space doesn't exist. That I made where you can see we've got just a grid of evenly spaced, evenly sized spheres, and you have a plane, okay? So check out like that one row, or that one, I don't know, that one plane of spheres directly on top of the ground plane. That's the one we want. We want to take that, but we want to make we want to randomly size the spheres and maybe move them a little bit. And then we want to take that and turn that into like a mask for the next layer. And then we want to do that again. First, you're going to have a plane like this, right? That is our ground plane. And then we're going to add some of these. But we want to take a version of this ground plane and use it to clip off of these, which we do. So we take like another version of this ground plane, but push it up a bit, and we use it to clip this so that these circles don't show up anymore. So that these, and it's going to be bad because it's going to just be, yeah. So then we'll have this, and I'm going to use this to get dark again. All right. Then we add the next layer. And of course, the next layer, it's more stuff. And of course, so these are just two of the circles. There were circles all over, but we cut everything off, so we only have these two. And so you end up with, let's see. I can just like, all right. I'm gonna have to just cut it really roughly. Well, okay, so I'll just do that, and then I'll be like, so you end up with this. Remember what we had? So it's like a circle, but it does that. So you see that. And then the next layer will look something like this. And then what we're pushing up is this stuff. So now we're pushing up this whole thing. We're going to go like this. See how it follows the path? Like it follows the shape of the last one. And that will cut off all of these. And then we're going to be left with, let me see if I can do it. Then we're going to be left with this. Right? So it's like it cuts off, and then it does that. And then here, it cuts off like that. So it's like circular underneath, but then it cuts off sharply. And then circular underneath. So we get that. So that's what, we do that every layer. So that we're masking, clipping, masking, clipping. So we're masking, clipping, unioning, masking, clipping, and unioning again. So do you see what the issue is? So we have right now a plane, and we want to mask out everything above the plane. So we actually have to take the plane, and we have to take the max of some like larger version of the plane. So right there, you can already see that it's not going to be like there's still going to be some amount of like distortion, but so we're going to take the plane. So let's split this up. So this is the plane as a distance. Basically, it's the distance from y plus 1. Well, it's distance from y negative 1 because we push up. So if you can hear that, that's like a car, just a car outside. So this is going to be our main distance. We're going to call it d. So we should still get the same thing here if we do that. Wait. not set base to field. Union masked union field with base. Okay, base equals union field with base. And then we repeat that again. Create a new field, mask the field with the base, and then set the base to the union of the field and the base. Create a field of spheres, mask the field with the base, set the base to the union of the field with base. So union of field and base. And base. So we're going to keep doing that repeatedly. Does that make sense? Create a field of spheres, mask the field with the base, set the base to the union of the base and the field. Okay? All right. Cool. More sense. Then fract. Otherwise, like, because I don't think this is the answer. Like, no, I mean, I don't even see it or anything now. Like, where is all this stuff? It's gone. That's needed. I mean, like, yeah, I guess I could do that. Okay, let's take a peek at the code. Base is like the plane, and then it's the next layer and the next layer. And then the addition step is the masking first, which is like smooth max masking. So that D minus 1 is like what I'm doing. And minus 1 times S. And then smooth min is where you're applying it, like you're taking the union with like a smoothing factor of 3 times S. And then you prepare for the next octave. That's like a rotation factor. That's also very helpful. And then the S is reduced by 0.5 each round. I'm multiplying. Wait. Oh, wait. The times 2 happening. Your first spheres. Hold on. Let me get rid of that so I can see. So you have your first set of spheres, then changing their shape, and then you push them down. So that's like the smooth min is doing that. Then you have the next set. So the change in size isn't as great as like half, is it? Like, no, right? Like, look at that. Like, that's huge. But then now it looks bigger. So maybe that was, I don't know what that was. And now it's suddenly, okay. All right. So what in the world am I seeing? So let's go back to this. This again. Whoa. That was fucking interesting, right? Swiss cheese. Look at this. Look at that. Guys, this is insane. What am I even looking at? How did this happen? That's really cool. Because, like, who's gonna believe it? Like, I started off being so, like, it started off so bad, and now it's really interesting. Like, what? Like, look at this stuff. Look at this. Who made, like, where does that come from? Like, what is that? It's the inside of the SDF that's, like, supposed to be terrain, but, like, it already looks like terrain. Like, can't I just flip this and look at it from the other side and, like I'd be there? But that's, like... And it's cool. So I don't really know what I'm supposed to be looking at, but why don't I... So I'm just going to explore for a little bit. And I'm going to rotate it. Yeah, what the F, man? What in the world is that? Whoa, what? That is so cool. Dude, what is that? Just randomly. What? So, what if I do this now? Okay. What if I do that now? I'm trying to go. I'm like, I've said bye like so many times. Fuck, man. That's what I'm looking for, though. This is it. Like, see how there's even more variation, I think? I don't know. I don't know. I don't know what's happening, actually. Like that. Like, look at that. That's without doing anything. This is just, like, this is literally just a bunch of circles that I cut up. Like, I didn't even, we're not even talking about smoothing it. And it already looks like that? Really? What? And, like, not even changing the size yet? You're kidding me. 5 somehow looks way worse, though. But 4 looks really good. 5, eh. But then does it matter? Because we're gonna be multiple sizes. That's gonna be better than, it's gonna be better. So we go 4, but that's like the coolest one, right? 4 here. 9 layers. Like, look at that. Look at that. Whoa. That's 9 layers. It looks like a real, like, look at this shit. Holy moly. I'm crashing out. Okay, and then I could change, and then we can change this again. Like, that's so much detail. Like, I can't even, like, my mind can't handle it. Like, I can't handle all this detail right now. Now, I don't know if this will allow us to make mountains, but maybe mountains is, like, relative to, like, how close you are into the scene. So maybe, like, they are mountains. It just kind of feels like everything is still flat, so I don't know. Damn, it's only been an hour and 37 minutes. But it's just like that starting point was like the start of the video, kind of like didn't know what I was doing there. So right, so what we have now is the most rudimentary possible version of the technique. We don't do any smoothing of the min or the max. We don't do any variations of the sizes of the spheres. I mean, the only thing that we do is that makes it random is we rotate the grid on some axis each time. And it already looks like terrain from a distance, like, you know, and that's also with no coloring. This is just normal. The stuff in the background is weird, but stop. Okay, but yeah, amazing, right? And then the floaties. I don't know what to do about the floaties, you guys. No. What if I did that? No. That's cool. Okay. I'm gonna continue this tomorrow. Let me just end here. I'm gonna continue this tomorrow. I might have to edit this video a bit to make me look smarter, basically. But otherwise, and also to put some of like the really exciting stuff like earlier in, because like I feel like the more I do this, the more excited I get. Like I got comfortable with you watching as I worked, because as I worked, cool stuff kept happening. And I feel like that's like something I can take away from this, because I feel like every time I do it, that's going to happen. And like when that happens, that's like more exciting than like this. Like it's more exciting that I'm excited by it than just the fact that like something is coming on the screen, because like at the end of the day, like the story of this project is my doing it. It's not the thing itself. Like someone already made this, and it wasn't me. But I'm doing it now, and it's really cool. but I have to edit it so that you can see that. But ideally I wouldn't edit as much because that takes a lot of time. So I might have to do like really like broad stroke cuts just to get the real stuff that is important. And then anyways, so thanks for watching, everyone, and I'm going to continue this tomorrow, and then when I have to edit it or something, and then I'll see you in the next one. All right. If there is some sort of kind of mix of autism and ADHD, then I might have it, or I might not. But I definitely feel like identifying as a robot is like a good way to kind of like, if you knew that I identified as a robot, then you would know how to feel about me. I'm a robot who just wants to have a good time. If you remember, in his article, he creates the base like this. So basically, oh, I get it. So instead of making a field, he makes a sort of Voronoi of all of the parts of the field. So let's go back to making a field. When I think about these letters, there's this one guy in this library at this university that I was working at, and it was a special kind of like room in the library that had all these printing stuff or printing capabilities, and including like generating different types of files formats. And so like I went in there to do something for like a 3D printing project, and I had to put like into the system, like I had to like sign up and give a reason why I was there. And I said, I want to do UV mapping because that's what I needed to do for this specific project. And so this guy is just like, so what is UV mapping anyways? Does that like have to do with like UV radiation? And I'm like, that's of course like that, you know, that's like the question that someone who has no idea what the math is behind the graphics would ask. And that's not a bad question, but it's like the fact that I didn't know the answer made him think that I was like, the way that he responded when I said, I'm not sure, I think it's more just like something else. And he's like, he looked at me like I was stupid. But the reality is that the reason why it's called UV mapping is because WX, I think it's just because those are just the next letters. Like, so W, X, Y, and Z are used for like coordinate spaces, right? And like graphics and, or like coordinate system stuff. And then after that, there's UV, right? Because TUV, WXYZ. So U and V are the next letters going backwards. And so those end up being used to define or to describe space, or to describe a surface, like the coordinate system on a surface. I think it's actually that simple. UV, it's only called UV because, well, I could just look it up right now. But anyway, so because of that, I was just like, it's not that stupid to not remember that, because it's a stupid reason to use U and V in the first place. I mean, it's not a stupid reason. It's a really, like, it's an arbitrary reason. It's like because W, Y, and Z were taken. Like, it almost sounds like a bad joke, but not letting me paint anything full screen. Anyways, we'll do this, okay? So here we go. So usually when you use fract, I'm going to make lines. You make a grid, because as long as you have coordinates that go from like 0 up to like some larger integer like 5, then when you use fract, you'd kind of separate that grid into a bunch of 0 to 1 spaces. When you draw a circle in that, without thinking about what like the coordinate space is, you end up drawing circles that start from here to here. But because like that other stuff is outside of it, you actually only get this part. So if you were to draw a circle in each of these spaces as it is, you would just get like this for each of these cells. You would get like one corner of the circle. I know these aren't real circles, but yeah. So usually to fix that, you shift the space so that it goes from -0.5 to 0.5. Then when you draw circles, they'll be in the middle of the coordinate space. But I feel like he's intentionally not doing that. And then when he's indexing each cell, when he's only indexing this way. Like he's indexing out from here to all of these, and he's drawing a circle in all of these, but in 3 dimensions instead of 2. So then it's like, he's drawing his circle here, but this one is also drawing its portion of it. And this one is also drawing its portion of it. And this one is also drawing its portion of it, which gives us the full circle. So that's why I think he doesn't have to do it, because if you do it the other way, if you go with this, if you shift the space so that you have the circles in the middle, and then you try to do this, right? Depending on how big the circle is, well, even forget about how big the circle is, you have a gradient, like this is a distance to a circle, like the distance keeps going out like this, right? And so if you don't draw this here because you can't see it, then like nothing is gonna fix that, because these only go up to here and the circle is already here. I think there's something like that. Anyway, so I tried my best. Okay, that's all I can do. So that, therefore, I think it's okay to do it like this. Right, let's have some food. So now I have that basic Voronoi thing where you start with a minimum D that's really high, and then you go through the loop, and for each like item in the loop, you shift the position to wherever it's supposed to be, and you create a distance. Ooh. You create a distance D, and then you find the minimum of D and minimum D, make that the new minimum D. And at the end, F is just going to be like min D. And if I return it, it should look the same. And it looks the exact same. So that works. Now we can make a hash function, or add a hash function in, so that we can change the change the size based on the actual, like based on the ID. And so we need a 3D hash function. And I think if I go to hashes, I have all of the hash functions. Let me just do this. Yeah, that's definitely, oh my God, like it's definitely like what I'm doing here on this other screen is super risky. Literally all of my, I don't know, some important information. It's okay. 1 out, 3 in. This is what we want. So I take this. That's a hash function. Okay, no issues. And then I'm going to apply... Whoops. Okay, laundry has to go from washer to dryer. All right. We're going to use the hash function to change the size of the sphere based on the ID. And that's for each of the shapes. Does that work? Will that work? I feel like that's going to be... no, it's the current ID, the current... Yeah, the ID plus the normal, right? Because it's like, we're doing plus because here we want to get the ID, the actual ID number, whereas here we do minus because we're actually shifting the 0. That's like a weird thing that you have to get your head around. And then the maximum will be 0.5, so it's times 0.5. So now, boom. So you see how we got, ooh, there's still a few weird things. It's not perfect. Oh no. What is that? Why? The only thing I can think of is that it's 5.5 is too high a value for it to show properly. Oh, you know what? I know. It's because we don't want to do this right now. Okay, now it's inside. I think it's just inside a sphere. Yeah, so does that look better? Does that look better? That looks better, right? More stable. So that's what we get. And I was right that having the 0.5, it's either you go to negative or positive and have like and have the fract minus 0.5, or you do it this way where you can go from 0 to 1 on each dimension and you have fract without the 0.5, which is simpler. And instead of using fract p minus 0.5, you would even just use round because that does the same thing. But here we go. So we got that. So now we were going to return this, and now we're going to do everything. So this is the moment of truth, okay? Well, first of all, so did I full screen already? I showed you the full screen effect, right? Yeah, so that's the full screen, but it's going... Let's just change this because I wanted you to be able to see the full thing. And the way it is right now, it's just, yeah. I just want a random value that lets you see what's actually happening there. The exciting part, are you excited? We're gonna add the field in. What? Oh, right, and change this to base. And so you can already see now that there's different levels of these. Does it cause floating ones? It might be causing floating ones, but in general, now you can see there's different different sizes here. We still haven't done the smooth minimum and maximum, so that's why it kind of looks weird. But even here, we go up to 8, and look at the difference. Wait, is that even better? I feel like that's worse. Is it? So I'm noticing more floaty things, but I'd say it's more random. I mean, although the shapes, it's like it's more obvious. Listen, it is more random. It has to be more random. It is like it's just, it has to be more random. Just add the smooth step. So this is like, if that wasn't the moment of truth, this is definitely the moment of truth. Instead of using min and max, we want to use smooth min and smooth max. Do I have that? And I won't get into exactly how it works, but there are videos on it. There's one by Art of Code, and I think there might be one by IQ as well. So you can see what that has done already. I don't know why it looks worse. But anyway, so it's kind of like everything is kind of melted into the surfaces instead of just being like out like that. The other thing that we might want to do is make it relative to the spacing, or no, relative to the scale, which is that S value that's changing every round. But we want it to be, so as the size of the shapes gets smaller, we want the smoothing factor to also get smaller, because we want it, because it needs to, we don't need as much smoothing for it to look smooth when the shape is already small. So we're going to do this now, and now we can see more of the shapes that we had. First, you're going to have a plane like this, right? That is our ground plane. And then we're going to add some of these. But we want to take a version of this ground plane and use it to clip off of these, which we do. So we take like another version of this ground plane, but push it up a bit, and we use it to clip this so that these circles don't show up anymore. So that these, and it's going to be bad because it's going to just be, yeah. So then we'll have this, and I'm going to use this to get dark again. All right, then we add the next layer, and of course the next layer, it's more stuff. And of course, so these are just two of the circles. There were circles all over, but we cut everything off, so we only have these two. And so you end up with, let's see, I can just like, all right, I'm gonna have to just cut it really roughly. Well, okay, so I'll just do that, and then I'll be like, so you end up with, this. Remember what we had? So it's like a circle, but it does that. So you see that. And then the next layer will look something like this. And then what we're pushing up is this stuff. So now we're pushing up this whole thing. We're going to go like this. See how it follows the path? Like it follows the shape of the last one. And that will cut off all of these. And then we're going to be left with, let me see if I can do it. Then we're going to be left with this. right? So it's like it cuts off and then it does that. And then here it cuts off like that. So it's like circular underneath, but then it cuts off sharply and then circular underneath. So we get that. So that's what we do, that every layer, so that we're masking, clipping, masking, clipping. So we're masking, clipping, unioning, masking, clipping, and unioning again. But what we want to do now, instead of having such a hard cut, we want to make it a softer cut so that things look more organic. So that's what we're doing with this S max instead of max. And we want to do the same thing where for different layers, the amount of smoothing is different. So if I press go now, you can see how that clipping, well, let's just show with just one dimension. We can show the difference. And to show what zero smoothing looks like, we'll just use 0. So if I change the octave to 1, so with 1 octave, and we'll keep it moving. So with 1 octave, we have this where we're clipping the tops. So there's a sphere, but it's clipped. And what we want to do is we want to add some smoothing to the min so that where it's taking the union of that clipped sphere and the plane, it looks smooth. So you can see now that there is like some smoothing, but we can make it more pronounced so you can see more clearly. It doesn't show as much on the smaller ones, but on the big ones, you can see now that it's smooth. And then we also want to clip, we want the top, the way that it's clipped to be smooth. So we're going to do the same thing here. So now instead of a sharp cut, it's a smooth cut. So now we want to do that for every single layer. And then we're masking by the smooth version too. So when we do that all together, that's when we end up with this. Oh, this is the start of it. So now it looks like this. And it's interesting. It actually looks like, it's weird. It actually looks like paint or wax dripped on something. It's a really interesting look already. That stuff in the background, I'm going to try to get rid of it, but that's what we have. Let's see. Let's see if I can get rid of it. If I can go, that's not the issue. How about the normal? Things that I changed last time, I'm kind of like going back on, wondering if maybe that's the issue. And this, that just makes it more obvious. Okay, we'll come back to that. So now let's go up 2 more layers, and you can see all the detail showing, at least in the foreground. Yeah, this is kind of weird. Like, it's kind of hard because I know when it actually gets uploaded, it's going to look worse, and it's already looking bad. So I do want to take a minute to see if I can fix this while I'm eating also. Oh boy. All right, so there are some issues. There's some issues with performance now. I'm not exactly sure what to do about that, because we're using 2 to the 3, we're using 8 taps like we're supposed to. It could be the hash function, but is that much more of a hash? Like, is that much more work? No, it's the same fract, dot, and fract, so it's not more work, so it can't be this. I mean, it might be more work somewhere in the system. It might still end up doing more work because there's more values, there's more variation in what the value could be. Like graphics cards sometimes work like that, where even if it doesn't look like there's a branching issue, somewhere in it, it actually ends up compiling as a branching statement, and that can be an issue. That's what I've heard anyways. But yeah, so I'll just pause it, and like, it's fairly random, right? Fairly decent. I'm just trying to deal with these weird lines that are like constantly like that's usually an issue with the accuracy of the shape, which is weird because it should be really accurate because we're not using the only reason why it wouldn't be accurate is because we're using smooth min and max now, which is what I was saying at the beginning. It's like we want it to be random or we want it to be a accurate SDF. So we don't want any sort of like changes to the field. We just want to apply more SDFs to it. But we're also going to use smooth min and max, which actually do add some random distances to the field. And that's why we're probably seeing all these lines. The more smoothing we add, the more the distance field is getting warped. So if I remove all smoothing, but then let's see that there's still a lot of it. So it's not that. So what else could it be? Then it could be the distance estimation itself. Something in the distance estimator isn't accurate enough. It could be the number of steps. Like if I reduce the steps, it should get worse, right? So if I reduce the steps, it's way worse. So what if I go to 128? It's better. The accuracy and like when we stop is if it's this, if we reduce that, don't really see much change. Let's see. I see some changes to the normals, but I feel like we can get some like we can win some cycles back. Like we can make it more efficient by not having this go so low. And then this we have more accuracy here because we add as much of it as we can. But this one is tricky because like I feel like yeah. So you can see clearly it's way less accurate when you do that. It's more accurate here. But what's the most that we can do? Here, not much of a win. So let's keep it to 95. So I feel like the most that we can win is by increasing the number of steps we take before we break. Right now, it's already kind of cool. It's like better, but very slow. So what if we reduce the far plane to 30? I don't notice a difference when I reduce the far plane because the fog already cuts off so fast. They're at 20? 10? Wait, what? Hold on. Yeah, okay, so now, so the far plane only really needs to be 5 because it just never gets that far because there's so much to do already. So they've reduced the far plane and it looks better. All right. So keep the far plane at 10 and then increase this to 48. 148. How much is that affecting things? Not much. Okay, how does it look on full screen? Better. Slow as F. It's like 5. That was like 5 frames per second if I saw it properly, but what else can I do? Because that's what I want to see. Like that's what I want it to look like. Like look, like this is what it should look like. It should show me the whole thing. And in the distance, yeah, okay, it's kind of getting weird, but I can even reduce the fog, or sorry, increase the fog. I don't know. Increase the fog to here. So now it just looks like, now you see, oh, wait, what am I saying? Come on. There we go. Yeah, now you can see kind of like the depth, right? Maybe even more. I don't know why. Yeah, okay. There. Yeah, so we got lots of depth. And which means we can reduce the far field more without seeing any issues. And again, I'm just going to go back to my other screen just to see how the performance changes. No real difference. All right. Right. So what we have now is, I mean, that's fairly, I am seeing some irregularities, but it's not bad. I think maybe the fog is too far, too close. I think that's something like that is more acceptable to me. Is that just not a good angle? Yeah, so that's with... Okay, so now let's put the regular lighting on. Boom. It's worse. This lighting is... This looks way worse. I'd rather, definitely rather use the normal. At least it's colorful. And... Yeah. Right. What else? Anything else? Then I was gonna make a sponge. So I was gonna cut this out of a shape. Ah, that's a lot. That's like a whole other story. I don't know how I'm gonna do that. I was gonna cut it out so you'll basically have a base, which we can just use a sphere as the base. I mean, we can do that right now actually. So we'll make a sphere and see what that looks like. So this is, ooh, that's a weird look. Okay. Let's make it like bigger. That looks almost like a planet. The frames per second is faster. So we can, this is a cool way to look at it, right? So here's a giant, yeah, it definitely goes way down on full screen. How can I feel like there's gotta be a way. Oh right, I know what I should do. Okay, what you would do if you wanted to speed things up, one thing that you could do is you could first try to ray trace a sphere around this object. So you basically teleport from like the camera right to like the start of the sphere, and then you ray march only inside. And if you weren't even going to hit the sphere with the ray, then you just don't even do anything. That would speed things up a lot. But I'm not going to do that yet because I don't have that, you know, I don't have that code available. I don't want to try to write it all from scratch right now. I'm not interested in doing a quadratic equation right now. So yeah, I'm not interested in doing the algebra around a quadratic equation, but it's like the sphere formula in standard form, I think, like the a squared plus b squared plus c squared equals, I don't know what it is. It's one of those things. And then you have to turn that into a quadratic equation and solve it. And then the roots of the solution are the points where we hit, and one of them might be negative, one would be positive, they'll both be positive, or zero. No. And there's something where it's like, you know, you didn't hit it at all if it's this. Something like that. Anyways, we don't have to do that now. Right now, I want to actually reduce the number of octaves to see what we got. This doesn't look too bad, right? We can also, ooh, ooh. Like if we're just looking for something that looks cool and we don't really care about like if it makes sense, that's pretty cool. Like these are like a whole new geometry here. Like this is geometry that I don't see a lot of this geometry on Shadertoy. Yeah, there's some floating stuff, but otherwise not bad. And of course you can reduce the floating stuff by doing something like that. I don't know. Okay, so yeah. And yeah, and also I wanted to subtract instead of adding it. So instead of taking instead of taking the max, hold on. Instead of minning, which gives us a union, we want to do another smooth max and add and then cut it out of the base. So we do this. And then we get that. There we go. So that looks pretty cool, right? But then we want, I think in this case, I want the max to have like a bigger, in this case, I want the max to be more maxy. And the min, I don't know. Like, I don't know. Oh, there's no min. There's just two maxes now. It's still too regular though, eh? Like it's kind of regular in a way that I don't like. And then you can increase the scale and you got all that stuff. But it's cool, right? Like it's an interesting shape. I would just say somehow make it more organic because it still feels kind of like, yeah, I don't know. Something about it feels like cut out. What if I do that thing now? So what if I do this now? This? There. Okay, so I can do that. And that looks more organic too. And also the size of the sphere I think matters. Because this is like the size of this sphere is relative to all, is not relative to all the other spheres. Which means like the bigger the sphere, the more the other things. So like I could do that. See what I mean? We could do this. But like I feel like this only shows me how much more regular it is than I want it to be. And part of that is probably this. I don't know. I don't know. All right. Part of it might be this. But then it's like, in some ways I actually prefer, you know what I think it is? I think it's like on some scales, I want it to be more smooth and on other scales, I want it to be less smooth, but not in this general ratio, in like some other ratio. Whoops. In some other weird ratio that I can't explain right now. But like, how's that? Like, isn't that weird? But I feel like I want the opposite of that. Which is that though? I don't know. And then there's this one. So there's so much stuff you can play around with. That actually looks better. Wait a second. So that's the field where you're cutting out the pieces. Which is weird in the first place. Like, actually, I don't... Ooh. So this is looking like a planet now. Like, these are looking like craters. The only thing is you would need a... There's a type of crater... Like, there's a way to create a crater where it's like there's a min, a smooth min, but it's not just smoothly subtracting or smoothly, like a smooth max is smoothly subtracting. It also creates a ridge and then it subtracts. And that's like a specific, like there's a function that can do that. I just don't know what that function is, but isn't this so cool? Like, look at that. And you can change that. Ooh. Ooh, yeah, like something like that. Do you see how like the choice matters so much? Like, yeah, something like this. And then increase the layers maybe. Like, I don't even notice. Ooh, there's a fly. Okay. And then if you reduce the size of the shape, then you'll notice it more. Like there's like a big hole under there. Increase the size and it's less showing, it's less noticeable. And then this thing. Right, that was what I did to get it to look the way I want. Something like that, maybe just a bit more. So you can see the other sizes. And maybe just reduce this a bit more. That looks so, like, delicious. Like, look at this. It's just... that's so organic. Like, oh my god. Ah, wow. guys. And so there's also a box version, which would be cool because a box is like the last thing that you would expect. Um, and this box is brought to you by Inigo Quiles. So is a Smooth Minute Max, by the way. Pretty sure. Pretty sure. Wow. But yeah, I almost choked. I almost choked to death right there, you guys. Trying to help. Not trying to help, sorry. I almost choked to death trying to share my passion. Look at that. It's like a block of cheese. It's like a block of cheese. But I wanted a smooth... I feel like I would want a smoother box. So we can just add something to it to make the box smooth. Yeah. Like, we don't want like a sharp box. Although that's kind of... that's a bit too smooth. Like... yeah, something like that. And now we have a box. But you know what would be even more cool? What if all of the shapes were boxes? And like rotated randomly. Like, let's try that. So instead of having circles, and this is probably the last thing I'll do because I gotta go, but I'm going to go to this function, and instead of using a sphere, I'm gonna use a box. And I'm gonna put all the stuff in here to make a box. I'm gonna go like this. And then I'm going to, and then the last thing that we need for the actual size is this. And then if I do that, ooh, box, no matching overloaded function found. Why? So there's a P, and then there's a 1. Oh, yeah, and then there's a 1. No, it's supposed to be a vector 3. My bad. Oh, and also, you know what? The cool thing is we can actually use not a vector 3. We can have different shapes of boxes. Oh man, look at that. What in the world is that? So these are boxes of a bunch of different shapes all put together. We might just want to have one shape. Like we might just want to have squares. So then that's squares. And this is like subtracting by different sizes of squares. Am I right? Yeah. And then we can go back to... let's go back to the ground. I just want to see what the ground looks like if it's all squares. And that's where we'll stop. So where's the ground? Here. So instead of using box or thing, we'll go back to the original thing. Plane. So that is the plane if we used squares. I mean, that is like the, yeah, that is a... why does it feel like... hold on. That feels weird. Like, that looks like not boxes. Okay. So it looks like this. Why? Why doesn't it look like... I feel like there's something wrong here. So it created a box with a different, like, different positions, randomized, and with different sizes. Right? Could do that, I don't know. Why is this increasing? Why? Hold on. What in the world? Am I missing something? Alright, and the other thing is let's get rid of this altogether. So it's just boxes. This is confusing. So those are our boxes. Why don't they look like... oh, I forgot. Yeah, so I'm also still using two mins. So let me switch I mean, two maxes, so let's switch that to a min. Oh boy. And then change that to that. So now we're using boxes. I don't know. Ooh. Ooh, there's issues with that. And then we'll just increase this. So we add 1, add 2. It's starting to get weird. That's actually pretty cool. Like, look, it's like geometric. Okay, 3. That's a really cool shape. Isn't that cool? That looks like low poly geometry. There's just some like random stuff going on though that I don't know what it is. I think I should try to fix that. There. How about this? There's still like this weird static I'm seeing. But anyway, so we can do, and that changes the shape. Like that reduces, like that gets, something like this, right? Cool, low poly look. Increase it to 7. Increase it to 8 or 9. And it looks pretty cool. And this 0, right? And then we can do that, like, do that. And that gives us like basically another type of ground. It's weird because I was expecting something like greebles, but because of the, yeah, and I don't know what that is. Anyways, I was expecting greebles, but I think because of the smooth steps, or the smooth min, sorry, and maxes, we don't have that. If I get rid of it altogether, so no smoothing, then that's as close to greebles as I think we'll get. Ooh, it's way, feels faster. That's another really cool look. Look at that. Very much like greebles. There's still a lot to look into and a lot to learn. But this is really interesting. So yeah, anyways, I hope you enjoyed this video, and yeah, that's it. And then, oh yeah, so should I tell you, should I say it? If you liked it, you know, subscribe and put the bell on, and like it and comment. And even if you do all that, the algorithm still might not let you know my next video, but just try to, you know, just try to like stick around. And also I have a Patreon. I've got a few people supporting me on there. I try to put my code on there so that other people can use it for what they want, but I ask for, you know, some support there. But and also this is on Twitch, so if you ever wanted to see me do this live and interact with me, so that it's not just bots, then you could also find me on there. I don't know when I'll be on next, but I'm going to try to do that. But yeah, ouch, yeah, that's it. Thank you for watching. Goodbye, good night, good morning. Oh, and I love you. Oh, the love bombing. Now you have to subscribe. I told you I love you. Okay.